Hello, Assalamu alaikum. This is Tasim Fuara Choa. Welcome to CSE 713 group presentation task 3. And our project title is An Efficient Machine Learning Approach to Detect Sentiments from the Text Data. And this is the name and ID of our group members. So this is the table of content we are going to cover in this presentation. First of all, let's talk a few about the motivation behind the introduction. Then we will move to the dataset. This research aimed to delve into the sentiment analysis technique with a focus on enhancing natural language processing or NLP system, decision making abilities, and mental health analysis. By understanding the human emotions, we can improve the accuracy of sentiment analysis, particularly in capturing mid polarities of the dataset and addressing the bias issues. The objective is to develop the methodologies that increase the effectiveness of sentiment analysis across various domains, leading to a more robust NLP system, better decision making process, and improved mental health monitoring and investigation strategies. So this is the data set we have collected for our project. We collect this data set that contain review of the Spotify app from January 1, 2022 to July 9, 2022 from the Google Play Store. The dataset comprises a total of 61,594 rows and includes 5 columns. 5 columns: time submitted, review, rating started from 1 to 5. 1 means bad or poor, 5 means excellent, total thumbs up, how many in that review, and reply of that review. So let's talk about the data analysis. First, the distribution of the length of the reviews by their rating. So let's go to the code for the better view. So this is the distribution length of the review. So let's talk about this distribution length of the reviews by the rating. So the histogram plot proves that the simple statistic of the text length we discussed, median of the review with 5 point, where is the point 5? Median of the review of 0.5 is 16. In the contrast, the median of the reviews with 0.1 is 35. So according to graph, we can say that the review with good points have the shorter sentences than the review with bad points. And these are the counts and the length of the text. Then the frequency of the ratings, or how many times the rating appears. So for rating 1, the counts is 17,653k, and for rating 5 it is the higher 22.095k, and for rest of the ratings it is lower than the others. Then this is the number of reviews over time. As you can see, there is a top peak at the March 8, 2022, that is 1282, and this sharp increase also occurs between 11 April to 23rd April 2000. Yeah, here 23rd April 2022. So for the next plot, there is the number of review over time for each rating. This graph shows the same thing for all the 5 ratings. And as you can see, for rating 1, it is the highest, and second highest is for rating 5. So there is a top peak. Now this graph shows the rolling mean of the rating over time for 7 days window. And now next we have the top 10 100 words before text cleaning, and then we did the data wrangling, and this is the top used 100 words after the text cleaning. So first we will see the top 100 words before the text cleaning. So as you can see, before text cleaning we have the word to multiple times 65,159 times. We have I, a, eat, for, of, is. This preposition and some nouns that is not actually necessary for sentiment analysis, so we can ignore this. So using the data wrangling, we removed all these maybe most of the words that has no significant effect on the sentiment analysis. So for this, data wrangling has been done. So for data wrangling, we use some methods. First of all, we lowercase all the text, then expanded the contraction, then we removed all the numbers, punctuation, emojis, non-Latin characters, and words less than two characters like I, A, is, of, then tokenized the text and removed the stop words, then we lemmatized the text and and then we did some additional pre-processing. But after data wrangling, the 100 words, top 100 words look like this. See, there is no I, is, that has no effect at all for the sentiment analysis. So this is the top used 100 words after text cleaning. Then additional, this is some diagram we will discuss later. So then we did some additional pre-processing, like we drop some rows, columns that contains null values. So these are the data pre-processing and wrangling. Then in our project we have used naive Bayes and RNN. This is the workflow. This part and rest of the part will be described by one of my group member. That is all from my side. Thank you.
Hello, my name is Samin Yasser, and I will be continuing with the presentation. So I will be talking about the methodology and the system architecture, as well as showing some of the code that we've run to get the results so far. So we've used two different models of naive Bayes. One is the multinomial, and the other is the complement. And we also plan to use RNN. So what is multinomial naive Bayes, and how does it differ from regular naive Bayes? In multinomial naive Bayes, the frequency of words is also taken into consideration, but regular naive Bayes does not take those into consideration and is more versatile. So this form of naive Bayes is more specialized. Now moving on to our code for the multinomial naive Bayes. Over here, we've run the code and we've found that the accuracy of the model is only around 61%. And this is the confusion matrix. Although the confusion matrix shows that the lowest and highest labels are mostly correct, the other labels are not that accurately distributed. Next, I'll talk about the complement naive Bayes. So complement naive Bayes seeks to address the issues of class imbalance in the training dataset by by considering the complement of the class frequencies when estimating the likelihood of the features or the labels. And although the probabilities are calculated a different way, the prediction process is exactly the same as the regular naive Bayes. Now I will move on to the code for the complement naive Bayes. So here's the complement naive Bayes with our 5 labels. The accuracy of this model is only around 55%, which is lower than the previous multinomials. The heat map is also very similar, where the lowest and highest labels are mostly correctly labeled, but the others are very mishmashed. And moving forward, we will try to merge some of the inner labels so that we get only 3 labels instead of 5, as well as implementing RNN into the code. So thank you for listening. This will be all from me.